We've got a really short little lesson thrown in here. It actually goes with the previous one in terms of our calendar. And the reason this lesson having to do with triangles is thrown in here is because we use the parallel postulate to prove one of these theorems about triangles, the triangle angle sum theorem. So you do need to make a flashcard for this postulate, the parallel postulate that says through a point not on a line, there is one and only one line parallel to the given line. So let's say our line is L. What this postulate is telling me is that if I pick a point anywhere not on that line, then there's only one line that will go through that point I picked that'll be parallel to L. So in this case, it was P. I can pick another point somewhere else no matter where I pick the point. There's only one line that will go through that point I pick that will be parallel to my given line. Okay, so I'm not going to work the proof of this triangle sum theorem, but it does use that parallel postulate in it, and that's why we have this little lesson in here. And so this triangle sum theorem, triangle angle sum theorem, is something that I think you've known for a long time, and it just says the sum of the measures of the angles of a triangle, and of course that means the interior angles. The interior angles, and those would be these. I'm going to put dots on them. Okay, those would be the interior angles, and the sum of those measures is 180 degrees. Okay, a blank angle of a polygon, but in this case we're talking about a triangle, an exterior angle of a polygon is formed by a side and an extension of an adjacent side. So if I go to my drawing up here, and let's say I extended this side AC. I could extend it in either direction. It doesn't really matter. But if I extended that side here, this angle right here that I'm going to label 1, that's an exterior angle. Okay, I could do another one. If I extended side BA, this would be an exterior angle. So that's what we mean when we talk about an exterior angle. For each exterior angle of a triangle, the two non-adjacent interior angles are called its remote interior angles. In the diagrams below, well, the diagrams below, it turned out are on the other page. So we're going to have to remember this statement as we go to look at the other page. In the diagrams below, angle 1 is an exterior angle, and angle 2 and 3 are its remote interior angles. So I'll repeat that when we get over here. Let's look at that. So angle 1 is the exterior angle. Angles 2 and 3 are the remote interior angles in all these pictures, not just one picture, but in all 3 of these pictures, the remote interior angles in all 3 pictures. And that leads us to the next theorem that says the measure of each exterior angle equals the sum of the measures of its remote interior angles. So, for instance, the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3 in all 3 of these triangles that you're looking at up there. So let's do a couple of problems. Find the measure of an angle of angle 3 if the measure of angle 1 is 102. Okay, well it says use the top. Okay, so I'm going to redraw it down here so I can remember what it looks like. Here's angle 2, here's angle 3, angle 1 is up here. So I know 1 is my exterior angle. So I know that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. That's what the theorem just told me. Okay, I'm given the measure of angle 1. I'm given the measure of angle 2. So now I just got to use the subtraction property of equality to solve for the measure of angle 3. And when I subtract 45 from 102, I get 57 degrees. Okay, you do number 2, come back and check it. I set up my equation using the triangle exterior angle theorem. I know that the sum of the measures of angles 2 and 3 equals the measure of angle 1, the exterior angle. I just substitute in the numbers they give me, and it turns out that the measure of angle 3 is 57 degrees. Same thing in number 2. Substitute in, but this time they tell me that the measure of angle 2 is equal to the measure of angle 3, which is 40 degrees. So I know that the measure of angle 1 is just 2 times 40, which is 80 degrees. And then what you have down here is just 3 more practice problems, and I believe that is it for this little lesson. So as you always do, you're going to pause right here, you're going to work these problems, and then you're going to come back and check your answers. In the first problem, the first thing I did was to recognize that y is an exterior angle for the little triangle out here on the left, and the measure of y is the sum of the 2 remote interior angles, which are given, 30 and 80. So y is 110. And now that I know that y is 110, since I know the triangle angle sum theorem that tells me that the sum of the interior angles of the big triangle on the right are 180, the sum is 180, then I know that 110 plus 40 is 150. That means z has to be 30, 180 minus 150. And then finally, once I get that z is 30, then that makes x the exterior angle for that triangle, and it's the sum of those 2 remote interiors. So 40 plus 30 is 70. And for the middle picture, I'm going to find x first because I have 2 of the angles of the triangle, so I just subtract the sum of these 2 from 180, which gives me 80. And then because of the vertical angles theorem, I know that x and y are congruent, the angles are congruent, the measures are equal, so y has to also be 80. And once again, for 14, I had to get out my colored pencils. They mark that these 2 are parallel, so I highlighted in my transversal. And then I could see they told me that this angle right here measures 30. That means this one had to measure 60 by the triangle angle sum theorem. And since angle C here is corresponding with this one, and I know that these 2 are parallel, I know C also has to be 60 by the corresponding angles postulate. You learned a lot of theorems in the last 2 lessons, so I hope you're making your flashcards and you keep studying those.